Okay, in this lecture we're going to go ahead and analyze a truss. We got this problem here. It says they want to know what is the member force in member CD, DH, and IH. We're going to use a method of section because it's the easiest way. Rather than find it, go method joint by joints. Just to do method of a section. One of the first things we're going to do free body diagram. So what I'm going to do, take these roller out and pen out, replace them with a force. I'm going to say, okay, this is going to be force right here, and that's a AY and AX. We're not going to do with AX because there's nothing coming this way. And then I have a EY. So let's go ahead and calculate these quickly. And we're going to say, take a moment. We look at the whole thing as one unit to find the reaction. One way is take a moment about either about this point or that point, doesn't matter. Let's take a moment about point E. Summation moment about point E is equal to 0. Our rotation going counterclockwise is positive. So AY is going to be counterclockwise. It's going to be minus AY time. What is these? These are, from here to here is a 2 meter. So that's a 2 meter, that's a 2 meter, 2, 2, 2, 2, 2, 2, all 2 meter. Okay, and the height also right here is 2 meters. So these angles are 45, nice and easy. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. That's going to be 8 times 2, 16. And then I'm going to have this one. It's going to be clockwise, plus 30 times 16, plus 60 times 12. Plus 60 times 8 plus 60 times 4 equals 0, and AY comes out to be 120 kilonewton. Okay, summation f of y is equal to 0. EY also comes out to 120. It's symmetric anyway. So I got 120 kilonewton right there. 120 kilonewton. So best thing to do this, just cut a section. If I cut a section from CD right here, cut it right there. And then we're going to go ahead and figure it out. Let me just redraw that cut in down bottom here. Do the free body diagram of it. It's coming this way right there. And it's coming like that. And it's going up like that. So this is going to be point D right here. And we have 60 kilonewton. And then we have 30 right here. Kilonewton, and then I have the reaction coming up 120, and this is a point I, and let's go to H. H is continues right here. That's H in here. All right, and then we cut it across. So one thing we're going to look at, we're going to say, let's say top is compression. I'm going to use a different color. Replacing, when I cut it, I'm going to replace it with a force. So CD is going to come up this way as a compression. And then let's call this also in a tension. That's going to be HI. So I'm going to replace HI right here. Come on, clean up. HI, I replace it with that force. Then we have this force coming down to here. And that's going to be kind of in tension, but if you make these assumptions wrong, this is a tension, then your number come out negative, then you know your direction was wrong. So, and that's a H, that's a DH. Remember, and this is we thinking this is compression, this is tension, this is tension. And then when I do my calculation, if these numbers come out negative, then we know these arrows are supposed to go the other way. So it wasn't tension, it should be compression. So let's figure out if we got them right. And now when you look at the free body diagram here, this is a 45-degree piece of cake. What do I got to do? I only have, I can take summation f of y, and I can calculate this one. So from this free body diagram, you cut this in half, now you have this as a rigid body. This all count as a rigid body. So summation of forces in Fy and Fx becomes 0, and if you take a moment bar, any point should come out to 0. So let's go ahead and take a summation f of y. Let me go just use a different color. I'll just stay with this. Summation f of y is equal to 0, going up is positive, and I have 120 minus 30 minus 60. Then I have this dh, it's going to be minus dh. That'd be sine 45. That's it. Equals 0. So dh is equal 120 minus 90 become 30 divided by sine 45, and that comes out to be 42.2. 42.42, and because came out positive number, then our assumption was correct. This is tension, and that's a kilonewton, so it's a kilonewton. That was easy. So let's go ahead and calculate the other one, and the other one would be, take your pick. So this is going to come in right here, and it's going to be right here, and this point, it should be dotted line, and that will be point H. So let's take a moment about point H. We're going to have, starting from here, it's going to be CD, it's going to rotate clockwise, so it's going to be CD times 2, that distance is 2. And then we're going to have 60 going to go clockwise, minus 60, and that distance is going to be from here to here is 2. And nothing, we have 120, 120 is going to be positive, it's going to be counterclockwise plus 120, and that's going to be 2, 4, 6 times 6, and then it's going to be minus 30 times 6 also equal 0. And our CD comes out to be, CD is clockwise, so that should be minus right here. Okay, so now the signs comes out okay, and that comes out to be 210 and correction kilonewton. So to do the rest of them, it's easy, just do summation f of x. Summation f of x is equal to 0. Going right is positive. This marker says I give up. It's going to be, I'm going to do summation f of x here. We're going to have hi, so that's a minus hi. And then we're going to have minus dh, which is a minus 42.42 cosine 45. And then we have a plus CD. CD came out 210 plus 210. And there's nothing else in x direction equals 0. And hi comes out to be, and we assume it was going to be in tension. That's going to be correct number. So it's going to be 180 in tension. See, it didn't take long. We finished it. So, summary. You have the whole structure. Do a free body diagram. Solve the reaction. Perfect. Then you cut them when you want to cut them, and you have another free body diagram, and then you solve those for this equation. If you like it, give it a thumbs up. Take care.